We're gonna do a small project here. I can feel that the engine isn't running so smooth when I get on the gas. So I think maybe the valves inside this will need adjustment. So we gotta like first measure and make sure they're within spec, or if they're out of spec, we gotta change the shims and adjust the valve clearance. So to do that, we gotta do a few things. First, we wash the bike, although I mean it doesn't look like it is washed, but it is washed. We gotta take the seat out, then we'll get the tank out. That'll expose most of what we need to do, and we'll go from there. The tank, you can still see a lot more dust. This is a good time to go and do another wash underneath the tank. Well, it's dark right now, so I'm not going to do that. So I like to put all these bolts back. For example, this guy, it came from here. So you could either put them in a tray or do this. I like to do this so I don't have to look for it. It's always going to be here. When I need to put the tank back, I just take this bolt off and install it and put it back. So I don't lose these bolts, and I don't need to keep track what bolt came from where. So that's what I usually do. So at this point, it's good to make some room if you want. We'll take the spark plug out, or we'll just loosen it so nothing falls. We don't want to remove it because then there'll be a hole and all the dust can fall inside. So we'll just loosen it, and then we'll take this off. With these two hexagonal stuff, whatever it's called, Allen bolts, we'll remove that, and that should loosen the valve cover. Okay, this is a good time to inspect the spark plug that came off. It looks wet. Not super happy about the condition of the plug, so we're definitely going to put a new one in when we finish the job. Okay, there you go. The two bolts, the Allen bolts, and that means this whole cover is now loose. We should be able to take it out. There you go. So that's the valve cover. The gasket looks good, so we're gonna reuse the gasket. We don't need to put a new one in, but we do have to clean the surfaces over there. And once we clean and everything, so we're not gonna change the timing. We're not gonna do anything else. If we have to change the shims, we will need to loosen the tensioner and get the shims underneath the buckets. But for now, first we got to put this engine in top dead center, and once we do that, we should be able to measure the thickness or the clearance from under here. It's a 5-valve engine. It's got, I believe, 3 exhaust lobes and 2 intake, or 3 intake and 2 exhaust. I can't remember, one of those, but it's a 5-valve engine. Check the valve clearance. So there are 3 intake valves. There's 1, 2, and 3. Okay, so I'm able to send 0.1 millimeter underneath the valve, the cam, and the flat dome here. The spec is supposed to be 0.1 to 0.15. So right now it's at the lower level, 0.1. I'm not able to send it in the middle one because the feeler gauge I have is too thick. I need like a thinner one, so probably we'll get a different one tomorrow. So most likely, if the two valves are out of spec, out of the 3, most likely the middle one is also out of spec. So it's safe to assume that this engine definitely needs a adjustment, which is a lot more work because you got to take out these bolts. The cap will come off, the camshaft has to come off, and then we got to remove the bucket, and underneath that is a shim. We got to change the shim to in this case we got to put a thinner shim, okay, because we are too tight. So now we got to go ahead and check the exhaust side. We're supposed to have anything between 0.17 and 0.22. I'm trying to send 0.17 and it's not going in, so we are out of spec on the exhaust side as well. So let's try something smaller. So we're gonna try 0.15 instead of 0.17. So let's see if that goes in. That doesn't go in either. So we gotta try something smaller still. Man, we have a Side, the one that went in was a 0.127, and that's quite a bit smaller. That's quite a bit smaller than the spec. So we got to move the exhaust side by 0.1 millimeter, from 0.127 to 0.22, or at least 0.2. So about 1 millimeter, sorry, 0.1 millimeter or 0.08 millimeter. That's how much we need to move on the exhaust side. On the intake side, we are measuring 0.1 when we should be between 0.1 and 0.5. So I would like to bump it up to 0.14 from 0.1. So we got to move 0.04 on the intake side and 0.08 on the exhaust side. So I'm glad we did this measurement now, because otherwise won't be good. The tensioner, the chain tensioner from here, and it's important to remember the orientation, how this came out. So you see the notch was to the top. There's no notch on the bottom. So when you put it back in, you definitely want to put it this way and not the opposite way, because it can go both ways. So you got to be careful which way you put it. Okay, so that's very key. Now you can imagine, once the tension's gone, these cams can move. They're no longer connected to the crank. So what we need to do, well, the cam's going to come off anyway, so that's okay. But it's important to make some kind of marking here, and also make a mark to hang this chain to the frame. That way the chain doesn't fall inside. We took a permanent marker and made a mark here on the gear as well as on the chain, and also on the other side. So hopefully you can see. Yep. So we'll try to use this to align. If not, it's still okay. We could either way do a timing check. We'll remove this, remove that guy, and make sure that the timing marks are where we want it to be, and we can align this in the end. So it really doesn't matter. We need to get those shims underneath these buckets. So these are called buckets. There's like 3 intake valves and 2 exhaust valves. So this is like a 5-valve engine. It's a very unique engine. So we got to get the shims out. So first we got to remove the bucket, and we'll try to get this out with a small magnetic pick. So you saw that the bucket actually came and got attached to the magnet, and I don't see the shim on the valve, so it should be attached here. And there you go. That's the shim. So that shim is the one that we need to change. So we got to go to a thinner shim. That way we get some clearance. So we got to get the shim out, and we got to measure. But first thing we got to do is make sure we note down which shim came from which valve. We got to number them. So what we'll do here is we will start writing it down. Okay. So let's say this is intake 1, intake 2, intake 3, exhaust 1, exhaust 2, and this is the air box, this is the exhaust, this is the chain, and this is the Kickstarter. Okay, so this way we will not lose track. So what we will do is we will measure the thickness of the shim, and then we will know what shim to order. The thickness, not the diameter. So diameter is 7.48. That'll tell us what type of shim we need. But the thickness is 1.89 millimeter. So we know from our earlier measurements that we are short of 0.04 millimeters. So what we need is actually a shim that's thinner by 0.04. So we need a 1.85 mm shim. So that's what we need. So we'll go ahead and drop this one here, and we'll go write that down. So we have here 1.89 and need 1.85 or 84, one of these. Okay, that'll get us in the ballpark. So we'll go ahead and take the second shim, the third one, and do the same for the exhaust. And we'll go ahead and order these parts. Okay. All right. These buckets can also have slightly different thicknesses. We also went ahead and named these buckets intake 1, intake 2, intake 3, so we don't mix and match the shims in the bucket, so the new shims we get will go into the same buckets that will go into the same intake valve. So this way we don't have any confusion. Exhaust measures 179, and if you see the shim itself, when it was manufactured, the size was 179. You can see it. It'll focus. Yep, 179. So this shows the shim doesn't really wear out so much. It's not the shim that wears out. Whatever you make, because it's just getting compressed. It's a hardened material, so it doesn't get worn out. It's usually the other parts that wear out. So whatever is made usually stays intact for forever. But I'm not able to read the numbers on these shims. Somehow they got like erased, but this one I was able to read, and it's the same size. Remove the last bucket. You see this little thing? That's the decompression mechanism that's actuated via a cable. This guy, okay, that's a decompression. So we got to remove this nut and take this out so that there's clearance for this bucket to come out. Right now is we just laid down the buckets and the shims that came out. Whatever shims we had, we just put it on the side in the same layout as intake 1, 2, 3, exhaust 1, exhaust 2. Now let's try and fulfill the needs now. So let's go to intake 1. We measured 1.88. We want 1.84 or 1.83. Now if you look, we know that intake 2 had a 1.82 millimeter shim, so we could slide this over and fulfill the needs of intake 1. So if we just take the shim from intake 2 and decide to use it for intake 1, that'll make intake 1 happy. Now let's go to intake 2. We measured 1.82. We need 1.70. That's 70. Yeah. Sorry, you need 1.78 or 1.77. So if you look, where will we find 1.78? Nowhere. So we'll come back to that. We have a 1.90 on intake 3. We need 1.85. Now you don't have 1.85 anywhere. It's bigger than most we have. We have a 1.88. That might be too big. It's very close to 1.9, so we will need 1.85. So if we go back to our shim kit that we just received, we will find 1.85 shims here. So let me pick one up. Okay, so this one says 1.85 on it, if it'll focus. Okay, so we have satisfied the needs of intake 3. We'll go to exhaust 1 and exhaust 2. They both had 1.79. They both need 1.70. Now we don't have 1.70 anywhere, so once again we will need to go here, and this one's 1.70. So we'll take one, lay it down. We'll take another and lay it down. So we have, let's see, this is also 1.7. So we got two 1.7s from the shim kit. Now the only thing missing is we need a 1.77 or 78. Now the problem is we will never get a 1.77 or 78. They always come in sizes like 1.75. Now I could use a 1.75 that would make this particular cam a lot looser, by, let's say, we are taking out 0.07, so it's going to be 0.02 outside the spec, okay, because we were off by 0.05. So if we put a shim that's thinner by 0.07, it's going to be 0.02 too loose. Okay, so that's one option. Now instead of doing that, what if I used a 1.79? So I have a 1.79 from here, right? What if I use one of those shims? If I use one of those shims, that'll land me only 0.03 from what we measured. So we will be tighter by 0.02, but we are still going to be in spec. So that's more important. So we want to be in spec. So the problem with that is going to be the next time we want to do an adjustment, this particular bucket and shim and valve will go out of adjustment first. But you know what? It's okay. We still need to be in adjustment. So let's slide one of these too. So I'm going to pick this because the numbers are worn out a lot more than the other one. So I'm guessing this will be a little thinner. So we are using one from here as a 1.79. That's it. So that's our final adjustment. So what we will do is everything that we just picked, we're gonna drop into the bucket, so we know this is our final choice. Okay. Now, having done that, whatever else we got, so I have a 1.9 here. So since it's an even number, I'm going to drop it into a 1.9. So let's say this is a 1.9. I just dropped it into that. I have a 179 here. Since the number is actually clearly printed, I'm going to drop it into 1.8. I got a 1.88. Now I could drop this into a 1.9, but I choose to just leave it here because it's too far from one end. So I'm just going to leave it separate. So if I want, I'll just measure it and I'll get to know what it is. So this way we have completed our choosing of shims. We can close this guy up so we don't lose anything. Okay, and we'll put these guys back in the bucket or in this cardboard box, and we'll try to do our assembly pretty soon. Okay, now I do have everything to reassemble now. Okay, so with these, they can go inside these slots and we could put those cams. But I have coming a set of exhaust cams from a YZ250 that has so this is the exhaust cam. This doesn't have auto decompression. Okay, so it's a manual decompression using the finger. Now I am having a set of YZ250 cams come in which have auto decompression mechanism here. I'm going to install those for two reasons. One, it'll have auto decompression, and number two, it's a slightly higher performance mid-range. So I got it used on eBay for a good price, so I thought why not just add that in. So I'll have the option of auto decompression plus a manual decompression if I want to. So I'm going to wait for those to come. Otherwise I could have finished the job today, but I'll just wait a couple days and then finish it. That's it for today. We talked about swapping the cams to YZ250 cams with auto decompression. So they just arrived, so you're gonna check them out, compare the two cam lobes, make sure they're okay. The online forums say they're okay, so let's check it out. I've placed the two cams one on top of each other. The one on top is the one with the auto decompression. You see the mechanism here. So what basically happens is as this spins, this guy will go out, and that's through centrifugal force. And when that happens, you'll see there's a pin here. That pin is the auto decompression. That pin keeps one of the exhaust valves slightly open at all times, but when the speed goes higher, this pin goes inside, which means it'll allow the cams to close fully, and then the engine runs normally, or the valves to close. Now you'll notice that even though one's from a WR and one's from a YZ, the exhaust cam grind and the profile is exactly the same. So they both, this one and the bottom one, have the same profile. The only difference is in terms of timing. So when I compare the timing mark here to the lobe of the YZ cam, and if you look at the same timing mark to the WR cam, you'll see that the timing mark and the cam lobe are almost on the same plane. You could say, okay, the cam lobe is one tooth to the top, or maybe one tooth retarded from the timing mark. Now if I look at the same thing on the YZ cam, you'll notice it is quite a bit more retarded. So I would say instead of one tooth, this is like two teeth retarded. Okay, now what that means is the YZ cam opens the exhaust later, and it would also close the exhaust later. So this is definitely a higher RPM cam design, or like orientation in terms of timing. So it opens the exhaust late and it closes the exhaust late. Now when that happens, you'll have a higher overlap between the exhaust stroke and the following intake stroke. So that means the exhaust cam and the intake cam could be having an overlap, which will help it maybe in the top end or maybe in the mid-range. So there's definitely a reason why they just changed the timing of the YZ cam. But the WR cam will give you a lot more bottom end, and it'll have like a lot of stall resistance, but the YZ cam will make the bike more fun. So I have the option now to install this either with the YZ position. So if I install it the YZ position, I'll install it with the dotted line on the cylinder head. If I want to do the WR cam position, then all I have to do is just cock it a little bit on the inside so that I can install the same cam but on a WR position. But I'm choosing to do it in the YZ position because the WR power band, even though it's very good on the trails, it's not like exciting, okay? But when we choose to use a YZ cam, why not use a YZ timing and have more fun and some potent? To complete our installation is we got to start putting our shim and buckets into the engine. So remember, we had already chosen the right shims for each valve. So this is intake 1. So what I would do is I would take the little shim that we chose and install it in its respective bucket. So this is the intake 1. It doesn't matter which way you put it. You could put it either way. So that's installed. Okay, now we'll install the bucket. On top. Okay, now similarly we'll do this for 2, 3 and exhaust 1 and 2. All the shims and all the buckets. We also moved this manual decompression mechanism and install that bucket. We still have the manual decompression available, so if I pull this lever, you can see that it's also possible to manually decompress. So we're going to have two options to have decompression, automatic or manual. Next up, we're going to remove this, put our spark plug in, and then start installing the cams, and then we'll put the chain on top of the cam and set the timing. We put the cams in, the chain tensioner, the right orientation. We torqued all the bolts, and then now is the time to check the valve clearance. So 0.15 goes in the two extreme ends, but it goes in tight. But the one in the middle is actually a 0.13. So it's still within spec. We have 0.03 to go to 0.1. So we are in spec on the intake side. So intake 1 is at 0.15, intake 2 is at 0.13, and intake 3 is at 0.15. So they're all within the spec of 0.1 to 0.15, which is good. Now we'll check the exhaust side. Exhaust 1 and exhaust 2 is at 0.2. So it's within spec of 0.17 to 0.22. So now we are good to put the engine back together, and yeah, we should be good now. So we put everything back. We just laid the gas tank over there, connected the fuel line. We haven't bolted the gas tank down. I changed the oil, put fresh oil in it because it's always a good idea to do that. And this is going to be our first start. Hopefully this camera can capture. So what I'm going to do is pull the choke. I'm going to use the decompression lever to kick it a few times. This is to mainly make sure oil goes through the whole engine, the oil pump and everything. Okay, now let's try and give it a. So this is top dead center. So it starts first kick. Now we'll stop it in a bit to check the oil level and see if there is any oil leak anywhere. Okay, so that should have circulated the oil everywhere, and we'll check the level and we'll watch for leaks. So the oil level is good, it's full, max. Right now, what I would do is I would give it a wash because underneath the tank there's a lot of dust. So it's a good time to wash the area in general. And we'll put it back together and that's it. Ride around and see how the YZ cam works. And just definitely need to put all these tools back. Yeah, that's it. So job done.